Okay, yeah, I'm doing a voiceover because there's a lot of wind outside. I don't feel like putting this stuff inside. I'm a little lazy on that. A wave is composed of some fundamental characteristics including frequency, the number of vibrations in a given second, wavelength, the distance from the top of one wave to another, period, the amount of time it takes to complete one cycle of vibration, and wave velocity, the velocity of the wave found through the formula V equals lambda f. Okay, in the first trial, we're going to test out the gummy bear wave machine and see if we can find the wavelength, frequency, period, and wave velocity of this wave. Okay, in the trial, we found that we had a wavelength of 286 centimeters with a period of 2.9 seconds. To find the frequency, we would take the inverse of the period, 1 over 2.9, to find that we would have 0.345 hertz. To find wave velocity, we will use the formula V equals lambda f, or velocity equals wavelength times frequency. So we're going to multiply 286 times 0.345 to find our velocity, which is 0.99 meters per second. Okay, I want to remove some of the gummy bears and the skewers in order to have the wavelength. Now with the wavelength halved, we're going to try out the machine again and see how it affects the frequency, period, and wave velocity. Okay, in our second trial, we halved the wavelength from the original trial, and we had a wavelength of 156 centimeters with a period of 1.43 seconds. To find the frequency, we're once again going to take the inverse of that, 1 over 1.43, to find that our frequency is 0.699. So interestingly enough, when we halved the wavelength, both the period and the frequency were doubled from the original trial. So now we're going to multiply the period, the frequency and the wavelength to find the wave velocity once again. 156 times 0.699 gives us our wave velocity of 1.09 meters per second. As can be seen, the wave velocities were very similar but not exact. This can be an error that accounted from measuring errors or just the wind interference or something. In conclusion, we found that wave velocity is remained constant despite the changes in frequency and wavelength. And then we also found that wavelength is inversely proportional to frequency. That's it. Thanks.